I think the sound, you didn't share the sound, maybe.
But, is everybody hearing the audio?
Unfortunately, we didn't hear you.
You need to reshare by clicking on share sound.
Stop share and share screen again. Go for reset the audio here. Just 1 second. Got it. Share screen. All participants saying everything should be okay. Share screen. Share sound. Optimize for video clip. And share. Everybody can see the video now? Okay, so I'll play it again and you tell me if the audio is running.
Yeah, we can see it. Istanbul Technical University, and today I will present a paper titled Computational Aesthetics of Low Poly Reconfiguration of Form. Low poly modeling is an emerging subject in the fields of visual arts, architecture, and product design. Although it is usually used in the game industry to optimize computational power usage in virtual environments, it has become a popular form generation method for the design industry. The computational medium proposes a wide range of possible methods to create a low poly model. Thus, it also enables a variation set for the abstraction of a form. The main operation in low poly modeling, which reduces the polygon numbers, configures the complexity level called the level of details in 3D graphics. Reducing the polygon numbers is not merely related to decreasing the complexity level. It is also oriented through reordering. Computational aesthetics historically based on these notions. Ordering complexity, defined as the primary measurement values for aesthetics by George David Berkoff. In this paper, the computational aesthetics of low poly is investigated concerning the reconfiguration of form. Top eyeball installation is used as a case study during this examination. Berkoff's theory is reinterpreted through the top eyeball case to understand the visual features of low poly form in terms of its computability. The study has 4 stages. First, the investigation of computational aesthetics methods. Secondly, the investigation of methods used for the polygon reduction. And third, the design process of the case study. And lastly, the analysis of the case study. Berkoff's aesthetic measure theory as the initial driver of the computational aesthetics field has influenced many disciplines' attitudes towards aesthetics, aesthetic perception, and experience. The question of how to formulate and measure aesthetics could not be free from human perception. Hence, the topic has been an interest in psychology, philosophy, art, and architecture, besides computer science. To define aesthetics, many researchers and philosophers have worked on unfolding the conditions term to enlighten the nature of aesthetics and how it works as a matter of judgment. Regarding the varying definitions, the aesthetics understanding in this paper embraces the conditions as states and the process as a generation. The cultural and social aspects are excluded. Low poly modeling can be defined as a reconfiguration of form by reducing the number of polygons as a formation. There are several operators for polygon reduction. Edge collapse and vertex removal logic has been used during this study via Blender and Rhino Grasshopper software. Top eyeball immersed through a low poly surface generated through folded papers. And as it can be seen from these photos, the form of the wall tries to embrace the weaver by spreading on the wall from ceiling to floor. During the design process, there are multiple models, digital, computational, and physical, and all of these models become inputs and outputs, and they also give feedbacks to each other. And according to this, the design evolves. And a visual feature classification is made due to the occurrence of the reconfiguration of form. This occurrence is twofold. First, the ones that arise during the design process, and secondly, the ones that emerge with the effects of light and shadow on the wall. As it can be seen from here, the first one is during the digital and computational model and at the projection mapping phase, and the second one occurs on the real model. Berkov constructs aesthetic measure theory on the relationship of order and complexity. And according to him, the ratio of order and complexity reveals the aesthetic experience mathematically. The basic formula considers complexity as the attention given to perceive the object, and the order is linked to harmony and symmetry. As the complexity level decreases, the aesthetic experience increases. However, he did not propose a formula for visual art and architecture. He classifies aesthetics as qualitative and quantitative. According to him, aesthetics rely upon some aesthetic factors, but these factors cannot be determined definitely. Instead, they can be estimated. These estimations structure upon unity and variety concepts, and three major factors emerge throughout this. The first one is unifying without losing variety positively affects aesthetic measures. The second one, creating variety without losing unity, refers to increasing order value. And thirdly, unity and variety has to exist in the various parts of the whole. If we look to the low poly generation and topo eyeball, regarding this point of view, it can be said that the first reconfiguration of the installation in the design process switched the second occasion of the qualitative aesthetic factors of Berkov. And the reconfiguration of form during projection mapping switched the first occasion where the aim was to unify the variations as a whole. Here, the polygon reduction was seeking for the variations, and unified variations as a whole for projection mapping can be seen through the image. Top-line composition is elaborated due to the vertices of the polygons to understand the characteristics of the order, and a feature classification is made due to proportion, horizontal vertical network, and balance relation. According to Berkov, the primary need is a center of interest and subcenters in a composition. The installation has one primary center and 8 subcenters. The vertical and horizontal network created from the vertices indicates the density of vertices in the XY axis. The lines get closer and look duplicated because of the placement of these vertices, although some of the vertices seem coincident either on the Y or Z coordinates, X coordinate, but they are not. In terms of the balance of the network, a reorganization can be done about these positionings. A definition is created to eliminate duplicated line clusters. The network is associated with a canvas resolution, and the main parameter is defined as resolution tolerance. As the resolution tolerance rises, the non-coincident lines vanish. A color coding is added to differentiate the density of the vertices and their relation with the center of interest. Pink refers to dense vertex classes, blue shows lighter districts. As the second fold of reconfiguration of form, light and shadow effects need to be elaborated. Rudolf Arnhem defines this fold as the aesthetic attitude in perception. He points out that the environmental conditions like morning or evening light expose an object's varying states, which causes richness of sight as intelligence or perception. And Berkov defines these varying states as the balance of color or light and dark values affecting the center of interest. And topo eyeball, as it can be seen here, acts as a dynamic entity through the movement of light and shadow effects. To conclude, local modeling offers a variation set in terms of compositional features, which are proportion, balance, vertical, horizontal network system, while protecting its unity through the analysis of the generated computational model. The design order increased in topo eyeball as the complexity level decreased. And thirdly, the generated computational model exposes the proportional issues of vertex positions. And creative switches emerged through human-computer interaction during the design process of the topo eyeball concerning the unification of the variations of design, especially in the projection mapping phase. And these creative switches are interpreted as aesthetic emergence of the unexpected outputs generated through the computational model. The results of this study will be used as an input for the computerization of a rule-based approach and the structure of an empirical study for human perception of low poly aesthetics in further studies. Thank you very much for listening.
I think I'm proposing for us to see all the videos and then have a discussion, if everyone agrees. Okay, so let me open the second video.
Hello everyone, I am Claire Duclos and I am happy to...
I have to reshare the screen, correct? Or are you seeing the video?
Yes, we see it.
Okay.
The problems encountered are often multi-criteria and under constraint. This paper compares different constraint handling strategies approachable to designer for processes involving evolutionary algorithms. Nowadays, visual programming facilitates interoperability and multidisciplinarity, making environmental simulation and evolutionary optimization approachable to architects. With these tools, it becomes possible to use generative techniques to design efficient buildings. A parametric model allows to create a set of solutions that a genetic algorithm allows to explore according to the result of the environmental simulations. To add a constraint handling methods to these general methods, we can choose between 5 categories. First of all, penalty function, which consists in degrading the score of the objective function. Second, special representation and operators designed for some particularly difficult problems. Third, the repair algorithm, which consists in modifying repairing solution to make them feasible, illustrated here on this slide. Fourth, method that separate constraints and objective function. The easy way is to transform a constraint into an optimization function. And to finish, hybrid methods that mix evolutionary algorithm and other optimization techniques. But in practice, designers who explore solution spaces are usually not computer scientists. Some are visual programmers and use optimization solver available in their basic versions. Nowadays, only penalty function, repair algorithm, and transforming a constraint into an optimization function are approachable methods for architects. To compare this approach, we tested these methods on a real-world project designed by Architecture Studio. The case study is a medical research institute. The objective was to optimize the solar protection system of the laboratories in order to maximize indirect the lightning. The system consists of a large triangular vertical plates. The shape of the triangles vary to create pattern in the facade. The problem contains feasibility constraint to avoid collisions between the blades and aesthetic constraint to evoke jagged effect of the pattern in the facade. So 4 methods was implemented on Grasshopper. Ladybug plugin was used for the direct and diffuse radiation, and Honeybee and Radiant for the lightning simulation. The Wallace solver with NSGA2 algorithm was used for the exploration during 14 generation and 25 individual for each method. We also use Python for some generative models. The first method tested is the penalty function. A penalty function was used only for the collision constraint. The jagged effect become an optimization function. This method does not exclude any solution, excepted the infeasible ones. It is easy to implement in visual programming because it's a simple parametric model. The difficulty lies in the definition of the penalty coefficient. The second method we call hyperparameters. It is a use of intermediate parameters to avoid infeasible solution, so the problem is no longer under constraint. Here we use the strategy of positions of points. Some points make a curve to vary the shape of the blades, and the other make another curves to create the orientation of the blades. With this method, the solution space is greatly reduced and the method is also easy to implement. But the number of control points of the curves is fixed. So many satisfactory scenarios are excluded from the exploration. The third methods also transform an under constraints optimization problem in a problem no longer under constraint. This time we used a rule-based generative process. Our algorithm generates blades one after the other in a way that respects the problem of collision and the jagged effects. These methods allow to generate aesthetically satisfying solution, but this particular algorithm contains a stochastic dimension that can disturb the search of the genetic algorithm. The last method used the same solution space as the first one, but every infeasible solution are transformed before evaluation thanks to a repair function that acts as an agent-based model. This method is able to generate aesthetically satisfying solution without overly restricting the field of possibilities. But it requires some programming knowledge to implement this type of model. And find the appropriate repair function is a difficult task. At the end, the best method is the rule-based method. The best solutions of the global evaluated solution come from this one. Then the repair function methods give good results, followed by the hyperparameter method. Finally, the most common method, penalty function, obtain the worst performances. But this study concerned a single scenario. The results could be quite different with other design problems. It would be interesting to experiment this method in the future on other design problems from practice in order to propose guidelines to designers that would orient their choice of generative methods according to the type of problem encountered. Thank you everyone for your time, and particularly thanks to my reviewers for their valuable advice, and also thanks to each partners of the architecture studio who support this research project and allow me to experiment innovative design methods on real projects.
Going on to the next presentation. This is
Hi, I'm Susanna Dickinson.
And I'm Alethea Ida.
We're both associate professors here at the University of Arizona. We're disseminating a recent upper division studio titled Climate Change and Design. It engaged students in the exploration and research of real-world impacts in conditions of the Sonoran Desert region of Arizona, USA, and Sonora, Mexico. The approach is one we identify as an interdisciplinary approach, as it integrates methods, theories, and tools from other disciplines. The pedagogy was interconnected, but based around these 4 frameworks that you see here. The first framework was titled Understanding the Problem and had readings which related to climate and comfort, boundaries, architecture of change and complexity theories, with additional texts on the Anthropocene, posthumanism, and new materials philosophies. Students at each stage had to diagram their understanding of the issue. The second module, Digital Design Methods, introduced multi-scalar digital tools and dynamic modeling techniques. The goal was not to promote any kind of scientific determinism, but to start uncovering the complexities of data, information, relationships, and flows. Examples of student work varied from cell growth simulation to optimizing radiation analyses and data mapping and studies of migrant deaths related to lack of water. We also had regional studies using GIS and various plugins. In this example, it was Docker Fossa mapping of regional watersheds and forest loss due to wildfires.
In the third module, we deployed students into fieldwork in the Sonoran Desert and border region. We introduced students to a diverse set of devices and tools for multiscalar observations and data collection research, engaging different phenomena from matter to energy to air and water. Some students documented differences in natural and constructed washes in the Tucson urban environment, and also utilized photogrammetry techniques and water quality analysis measures and sound recordings. Students also utilized microphotography and IR thermography to understand plant physiological mechanisms. The culmination of the theory readings, digital methods, and regional field research led to a series of emergent design proposals. The range of topics and contents is diverse, each with different scales of emphasis, and each with different intentions for outcome and impact. The students' work with the natural and constructed washes resulted in a concept for a Sonoran symphony, integrating nature and natural elements to encourage different acoustic qualities. Another student explored the potentials of 3D printing techniques with regional soils for asylum seeker deployable housing. And another student was working with a kinetic wave concept, which integrated a kinetic structure that was collapsible and expandable in correlation to different flood levels within a wash, and also allowed for projection mapping with a Connect device so that there was the ability for transborder communications.
This project investigated the regional electromagnetic fields as well as low frequency radio waves at the border wall with an anti-radio device. Documentation of these recordings began to reveal patterns and gaps of both communication and energy fields. The resultant design proposal conceives of the border wall as an antenna, and it articulates this performative quality of the existing border wall by manipulating the fins to optimize radio and communication waves and allow for individuals to interactively transmit their own messages. We'd like to thank our college for the SEED grant to help fund guest critics and lecturers, field tools, and various other items for the studio. There was a lot of input from other members of various departments of University of Arizona faculty, and of course, all the students that were involved.
Ladies and gentlemen, it is an honor for me to have the opportunity to address such a distinguished audience. The subject of my presentation is Interactive Virtual Soundtable, an improved alternative participatory design tool for urban design. Participatory design is an effective means to improve urban planning. Various methods and tools are applied to participatory planning, such as innovative technology, immersive geographics visualization, augmented reality, and gaming. However, there is still a gap between the need for public interaction in participatory design and the capability of current participatory design tools. Participatory design is not popular in China, especially in rural planning. The problem is that most of the local population does not have the relevant expertise or the ability to manipulate complex tools. It is difficult for residents to achieve good communication with designers. So it is block the way for rural development. Therefore, to address this challenge and needs in China, the study constructs an interactive virtual soundtable. This paper introduces the framework and solution for the present problem in China. In addition, we also discuss the planning method of interactive virtual soundtable in participatory rules. This study is to provide an easily-to-operate and multi-person collaborative interactive virtual soundtable to improve participatory rural planning and design. It offers simply operation in the air, such as using gesture to trigger changes to virtual models or to control changes to virtual objects. The interactive virtual soundtable can be easily projected onto any planning display, and multi-user associate 3D glasses can see a three-dimensional virtual model. Interactive virtual soundtable base Unity development environment and Mocha SDK for Unity development kit, and we can use live motion and exports for interaction. Interactive visual soundtable includes 3D visualization, interactive design, scientific analysis and evaluation. Interactive design feature landscape elements such as roads, building, lots, and planning boundary directly. The interactive visual soundtable will record building locations, planned development and modification, and export its only record design activity test. Using typical workflows of participant plan, we can obtain the specific interactive visual soundtable characteristic requirements. Participant design is divided into 5 stages. Interactive visual soundtable is mainly used for Stage 2 presentation, Stage 3 discussion, and Stage 4 evaluation and modification. The point is that in Phase 3, we use the interesting ways to engage people in design. They explore their design idea by complete the game's task. This study tests the agricultural planning of Chaozhou City, Guangdong Province, China, as an example to test the feasibility of this statement in rural participatory planning. We invited 20 volunteers to be participants in this experiment. 17 non-professionals and 3 designers were divided into 2 groups. We have 2 rounds of discussion. From this project, we found that the way to use games was much more fun, and the way to use gestures and clicks was much easier. Too many participants would affect interactive visual sound tables work. Interactive visual sound tables is non-professional friendly and give designers some data. Our findings suggest that the quality of 3D visualization is not their focus. Ease of use and improve multi-person identification of interactive visual sound tables is one of the significant issues of participatory planning. Interactive visual sound table cannot currently test the remote participation of these stockholders who cannot participate in face-to-face interview and discussions. Therefore, interactive visual sound table allows stockholders to participate remotely and simultaneously in technology identification. We'll focus on our future work. That's all. Thank you.
Going towards our last presentation.
I am Veli Mustafa Önder. I am a PhD student at İzmir Institute of Technology Architecture Department. We prepared this study together with Professor Dr. Fehmi Doğan and Assistant Professor Dr. Hasan Burak Cavka. I will present the article titled The Shifting and Forecasting Characteristics of Bodrum Houses Using Artificial Intelligence Approach. The classification and clustering process of Bodrum Turkey houses are important to conserve the cityscape. This paper aims to classify and analyze the facades of Bodrum houses by using deep learning models, comprehensive digital database, and artificial neural network-based clustering methods. In this study, we are proposing to demonstrate how AI could be used in identifying the characteristics of Bodrum houses and in future studies in projecting potential avenues of evolution of these houses based on identified procedural change in vernacular. Computer vision, artificial intelligence, machine learning, and deep learning applications, which are among growing technologies, have the potential to be effectively used in fields of architecture and construction. According to Giro, it is normal that artificial intelligence and its methods are effective in field of computer-aided design. Artificial intelligence provides a huge opportunity in the architectural constitute classification and clustering with providing a more informed approach. In recent years, studies about architectural style recognition and intangible tangible heritage classification via machine learning systems were implemented. AI term composed of machine learning and deep learning terms. Machine learning, which is a sub-branch of the artificial intelligence family, is older than deep learning in terms of implementation areas and origin. According to the 5, it includes the methods of processing data with supervised, unsupervised, hybrid, and reinforcement learning algorithms. Also, according to the Mitchell, machine learning is critical for data mining, difficult to program application, and customized software application. Another term is deep learning, a sub-branch of machine learning, consists of more hidden layers, hence it is called deep, and it is different from shallow networks. Convolutional neural network is deep learning algorithm. It consists of input, subsampling, convolution, pooling, dropping out layer, etc. According to the title, an artificial neuron is made up of input vector, synaptic weights, bias, output, net information, and activation function. Its system works like black box, so inner actions are not known. In the white box, all actions can be explained by statistical means. According to the Bohlin, gray box is blending of black box and white box. In our study area is Bodrum Peninsula, located in southwest Turkey, has a hilly terrain and raw coastline. The town of Bodrum, located on this peninsula, generally consists of 2 or single-story buildings in harmony with the landscape. Bodrum, which was built on the old site of Halikarnassus, it has a dense urban texture due to the increasing construction and parcelization implementations in recent years. While Bodrum developed in recent years, preserving the conventional civic architecture examples became more and more important. According to the
我还有半个小时。
types of boardroom houses, kiosks,
我
and
是
general
行。
houses they are single story houses. They have a square or rectangular plan.
5分钟我也答不上来啊，
And they are
真的一点都没有准备，答不上来。
methodologies
不
of
行，还有半个小时啊。
Hello, who is speaking right now? There's someone speaking in Chinese.
Yao Chen, you have your microphone open. Can you please mute the microphone? Yao Chen.
老师他在叫我，老师他在叫我。
Yao Chen, can you hear me?
Yes, yes.
Can
I
you
beg
please
your pardon.
mute your microphone?
Sorry.
Cut your microphone, please.
second stage is about work packages to classify such images of houses through machine learning algorithms and image embedding with deep neural network models. Images were labeled as boardroom houses and modern residential buildings. The third stage is about constructing database and neural network-based clustering analysis by utilizing the numerical properties of facade elements of boardroom houses. The data editing stage, which is the subsequent part after the data collection section, consists of cleaning, sorting, and arranging the various facade images obtained. Boardroom houses and modern residential buildings facade photos were collected. Image classification stages are based on data collection, image processing, feature extraction, and use of classifiers. In this study, modified SquareNet, which was developed by Ayandola et al., and Inception V3, which was developed by SIGraDi et al. Architecture, were used as image embedder. After embedding process, classic machine learning classifiers such as support vector machines, random forest, and logistic regressions were used. According to the classification results of the facade images, the highest classification accuracy value was when SquareNet and support vector machines were operated together, and the lowest value was the situation where SquareNet and random forest were operated together. The confusion matrix shows the accuracy of the predicted samples of different learners and models. The highest value of this ratio for boardroom houses was the case where the Inception V3 network and support vector machines algorithm worked together, while the lowest rate was observed as the case where SquareNet network and random forest classifier work together. The area under curve value should be close to or equal to 1. The maximum area under curve value was calculated as 0.898 in this study. The highest value of this ratio for boardroom houses was the case where Inception V3 network and support vector machines algorithm worked together, while the lowest rate was observed as the case where the SquareNet network and random forest classifier worked together. According to the database results, the facades of 62 boardroom houses were examined individually, and it was found that there were overlapping groups in the number of stories and type of facade material. Before clustering operations, since the database contains different data types such as areas, numbers, and numeric values were aligned between 0 and 1 via normalizations operation. Agglomerative hierarchical clustering analysis was performed to monitor the units for the neural network-based clustering process. When the dendrogram graph was examined, 2 clusters were formed the truncation line. There are 5 groups in subunits that are in homogeneous distributions. According to the neural network-based clustering process, cluster 3 has a maximum weight of within the 5 groups formed in neural network-based clustering. When the profile graph is examined, all the numerical values of this cluster are very close to the average values, except the terrace and facade material. In discussion part, due to the superior abilities of artificial neural networks in problem-solving skills, both theoretical and implementation areas have been enriched. In the stages of defining and cataloging architectural constituents, semi-automatic or fully automatic process can be performed instead of manual with computer-aided artificial intelligence-aided systems. With the classification process, it will be possible to identify and categorize houses, and it might allow us to predict its possible elaborations. The dataset in this study is less than 500, as data augmentation methods such as rotation and translation are not used. In future studies, it is planned to use artificial intelligence to identify architectural styles and typologies by enriching datasets. The references for this presentation, and thank you for listening. If you have any question or suggestion, please contact with us.
Oh, stop sharing. As I mentioned before, it's very, very diverse research that was presented in this session. And at the same time, that's very diverse. There are very interesting common grounds between the presented research. If you look at the first three, you can see connections that would permeate the three of them. And then if you join the last three, you also see connections between the three of them. For example, a clear connection could be made between the work of SIGraDi and I forgot the name from the lady in France, where she could explore similar approaches to aesthetic explorations on the facade protection as was presented by SIGraDi. So that could be a potential connection. And then when looking at Susanna's and Aletia's work, you look at the same opportunities or similar opportunities to discussion about aesthetics and optimization processes, since you're looking into more complex, multivariate components, let's say feeding the subject of design. And obviously, the approach is quite different. You're not looking for optimization of any particular component, but you're actually incorporating multi-criteria to your design work. So that's a very interesting component. Then when you look at Yao Chen's work, the and Veli's work, you see the different potential for integrating multi-criteria and focusing on this multi-criteria as to get to similar results that could, how to say, feed, inform, let's say, design solutions. So when you look at Yeli's work specifically, one thing that came to my mind was that integrating it with the discussions about optimization that were presented on the second study, there's a clear opportunity to actually look at it from a Pareto frontier line to understand whether is there a Pareto border that could be explored in this scenario, and also the idea that you might be able to use it's called Terry Knight's work. I'm forgetting the name, just blank now. It's called shape grammars. The concept of shape grammars could be a different approach to your work as well. So those are the initial aspects that I was looking into. And then Yao Chen's work in connection with Susanna and Aletia's work could be a potential integration for a design studio. You can imagine how rich it would be a design studio where you have an immersive environment that people could directly interact upon the design. So those are the initial connections that I saw between all the presentations. It was very interesting from my perspective to try to build this tie-in between your work. And I would like to see your own comments and questions on this set of presentations.
Or if you have any specific questions, you may ask. Otherwise, I do have a few comments to make.
Go ahead.
I have a question to Susanna and Aletia. Okay, so their work was linked with actually the education, so student works as far as also we see. So first of all, how long did it take to execute that process? Some of them really looked very, developed. And what kind of expertises or what kind of backgrounds all the students, are they architects or are they design students? So, or landscape, are they from landscape architecture? So I was wondering about these simple things.
I can answer that really quickly. It was one semester, so ours are 16 weeks long, and we had a mix of undergrad students in their 5th year undergrad students, 2nd year Master of Architecture students, and 1st semester Master in the Science of Architecture. And so they were all architecture students, but our post-professional, well, our graduate program, the MS Arc, sometimes they're having different background, and the MArcs are coming from different kind of backgrounds. But does that answer? And so, yeah, so that's why we had the kind of the first two examples, because just to try and get everyone on the same speed with the digital tools and the kind of theoretical background.
Thank you.
I thought you had a very interesting setup with the frameworks, the different frameworks that you were proposing for the students. So it creates a good immersion process into the discussion. And that's one of the key elements that most studios fail in actually achieving a result that permeates and connects the lines of thought all the way from the conceptual aspects to the final design. So you can actually see the tie-in from the results from the first module to the last module. So that to me was very impressive. I had a question on the later side, on when you're actually going to the digital modeling and visual programming. How much of authorial programming is happening, and how much of appropriation of, let's say, online available programming solutions are being, let's say, you can talk about geometric appropriations and you can talk about definition appropriations. So to what degree are we talking about authorial definitions, and to what degree we're talking about geometric appropriations or definition appropriations?
Yeah, just to, and Alethea obviously jump in, I would just say that is, to me, is one of the keys with Studio, especially related to digital methods, is that my critique of, you know, our curriculum, if I was just going to be very kind of broad-based, is that there's no time in Studio given to learn the tools or the methods enough. You know, those are often in supplementary classes. So that translation, so giving people the time to explore, and obviously the weaker students appropriate more stuff. But luckily in that kind of environment, the stronger students, a couple of the ones, particularly that last example, were pretty advanced computationally. Yeah. And it really was a kind of new discovery of information. I mean, it's hard to know exactly what is out there. Someone else may have, you know, but it was, you know, pretty kind of refreshing. And that, I think, their knowledge helped translate and move the kind of the weaker students forward too. So yeah, it was a real mix, and that's the thing with a state institution. Really, usually we have a really broad range of students' kind of natural abilities and kind of background strengths. But that's, and it kind of was positive during COVID, that because this happened during COVID last fall, that actually we found ways of collaborating, and, you know, it kind of forced us to kind of, not in the way that Yao Chen, we weren't do it kind of in that immersive way, which is an exciting kind of point to move forward, but you know, it did force us to kind of people to work together more, which was a positive.
Okay, if I may, I would pick it up from discussion. Well, including the first two presentations. Well, Claire Duclos wasn't here, so Susanna and Aysegul Kavakoglu. So, Dr. Dickinson, picking up on that idea, what's the expectations for, well, from the studio, from the collaborators? What's the expectation for students furthering the practices and the tools and the concepts they employed during the activity afterwards? Is there any expectation? Is there a course that's laid around this idea, which is already programmed, or is it something that is there to open the minds of the students? I mean, complexity studies is such a huge field, right? And also, just to finish the first block, Dr. Kavakoglu, I was fascinated by the idea of aesthetics and directed at the low polygon geometries. And I was remembering last year on SIGraDi, we were working with biomimicry and very organic shapes as a technical and also aesthetic solution. Do you think how do you think these two ideas measure up? Are they complementary, or how does the low poly, which is very symbolic of computational graphics, and the biomimicry and organic shapes, how do you think they complement each other, or do they compete?
This is a question to me, right? Or
yes,
okay, okay. So, well, no, I haven't actually thought about biomimicry and its, you know, integration and its aesthetic values. So, but if from one point of view, you are right. Actually, biomimicry actually is based upon the proportions coming from the nature, and they have already has been studied very, very much. So this can be also very interesting. Well, I haven't thought about, you know, merging low poly with this kind of forms, but for now I'm just trying to work on this abstractly. Also, we are a team, so I'm trying to understand also its characteristics. I mean, what kind of, you know, features it has, so that it can be measurable. For now, it is like impossible to measure all this, because also there are other aspects, like when it comes to biomimicry, also we need to exclude many parameters. In this one also we have excluded many parameters, so like culture, society. So aesthetic value is very argumentative, but that's a really good idea. Yeah, it can work to have a look at also. I don't know, I couldn't answer it.
I'm just asking myself whether they compete or whether they can be combined as two very contemporary approaches to aesthetics, right?
Thank you.
And Susanna or Alethea?
Yeah, I can speak briefly. So as Susanna had mentioned, we had students from 3 different programs in our studio, and the Bachelor of Architecture students, they're in a sequence where our studio occurs before their final semester. So the hope is that as an option studio, that these methods and, as you said, kind of opening up the ways of thinking through the theories and the tools and techniques would be carried into their capstone thesis work in the subsequent semester. And that's also for the MArch students as well. They're kind of in their final year. For the Master of Science in Architecture students, this is their first introduction to a 3-semester sequence in the program. And the idea is that it provides a framework for a platform for their own research trajectories. So we really did reinforce this notion of integrated research and design processes as a kind of, you know, iterative model throughout the studio, and hope that all the students could carry that forward in their subsequent work.
Interesting. Dali, I would like to ask you a question concerning the underlying assumptions. When you talk about AI in analyzing any specific urban context, right? And you look into the possibility of decomposing the ways of reading either geometry, typologies. What results are expected in terms of intervention, in terms of design intervention, using these types of information? So, for example, in shape grammar studies, there was one specific case where they did a case study on Álvaro Sisa's work, and then asked Sisa to identify his designs and the designs that were generated by the shape grammar. And apparently he wasn't able to identify those. So to some extent, you're saying, look, through this analysis, through this recognition, we can generate solutions that are similar to, right? So that's the underlying assumption. So what are your assumptions? What are your expectations? Are you searching for a way to automate similar solutions? Are you looking into integrating maybe contemporary forms of living or contemporary social components, as was presented in other work here, to, let's say, improve or modify, not necessarily improve, modify present solutions? What are the expectations?
Veli, actually,
Sorry, I'm sorry. My mute is off. Actually, AI works very kind of works. Some of the are using the classification process and also segmentation, pose estimation in architectural field, also computer vision field. In your mention is that the generative adversarial neural networks, they are using, producing synthetic data, and not just only for architecture, but also producing fake images. But these fake images is more similar to the real images. And some of the works was implemented for artificial plants, and new studies were implemented for 3D models. And this kind of new models was helpful for architects or designers to select alternative design ideas.
I think I understand. So one of future steps would be probably identify some kind of Pareto border that you could explore optimized solutions.
Okay. Yeah. In my case, in my studies, the classification process was helpful for restoration or heritage students. But in generative adversarial neural networks, was helpful for design students.
Understand. Do you have examples that you can share with us later on?
No.
Let's say links or anything that you can share, because that's very interesting.
Okay, I will share.
I think Yaoshan, on the same line of thought, do you have examples of the results that were explored on this digital send table? Or anything that came to, let's say, what other than the interaction, because that's in itself very interesting and important, were there design explorations that could be, say, discussed here in terms of opportunities, either for educational settings or the similar settings to the ones that you just presented? It's muted.
Doctor, your microphone is off. to hear us.
Okay.
Sorry.
Okay, good. No problem.
Let me think about it. I think you have good idea, but my paper, it is still in process. I will try to think about it again, and let us discuss it later. Thank you.
No problem. No problem. I think that's you have a very interesting research proposal, and it surely has applications in design studios, and we've seen in other SIGraDi and Acadia and ICADI conferences explorations that are aligned to what you're pursuing. So I would be really interested in seeing how your work evolves and incorporates some of these previous research. So that's a very interesting component also to pursue. So thanks for your presentation.
Right. I would also like to, well, leave some comments for Yao Chen. I think they have the presentation has been very clear in that including the citizenry in participatory design has a few, well, hurdles that we have to overcome, right? One of these is getting access to the people, or physical access, and one of these concerns, well, it's already pointed out that they will be the team is going to be trying to work remotely. I still have some concerns as to how the gear, the physical equipment is going to be distributed, because I do work with participatory planning as well, and each time we try to do anything, we try to do it as well as simply as possible. I mean, materially speaking, using being as low tech as possible in order to reach out the population, which is not always familiar with technology. But I think that the send table design could be a great way to incorporate, because it's very physical. But then you would have to bring the people to the send table, or take the send table to the citizens, which may be a hurdle. Valley, I was thinking, watching your presentation, I was thinking, have you considered, well, two issues. First of which, how does the AI react, since you're working with heritage sites, right? How does the AI react to different stages of facade damage or degradation? Because quite often when we are working with heritage, we're working with damaged buildings, at least exterior facades. And have you considered combining, well, Street View data, I mean, working with Street View, Google Street View, and applying your AI and trying to map the heritage sites on GIS?
Yeah, it's the crack detection is also important for image classification procedures, and lots of works were implemented in this field, and not only architectural heritage field, but also civil engineering and earthquake engineering field. And as you mentioned, Google Street View images, I think it's very useful for image recognition, and it's also useful for street and also neighborhood classification procedures. Yeah, and combination of these two different topics and crack detection and also classification facade is very effective for computer vision.
Yes, because I imagine you could use the regularly updated Street View data in order to create sequential maps from different time periods in time and kind of follow how the degradation is happening or how the heritage is being restored or lost. That would be an interesting work to see, right?
Yes, it's totally true. Actually, large data sets for images or videos or point clouds, whatever, is very, very important for AI. So, but the most important thing, the distortion, rotation of images, also noisiness and color filtration process, and is a very huge problem.
Thank you.
Right.
Does anyone want to ask questions to peer presenters?
There's no one here from paper number 2, right? The second group?
No, there is.
Yeah,
I had questions for them too.
Yeah, on the evolutionary. Yeah.
Yeah, I mean, I'm excited to read everyone's paper. I haven't done that yet because I'm not sure we had access to them, or maybe I missed that.
No,
But,
you didn't. We had access. That's because we're moderators. We had access to your videos previously, and we had access to your paper. So we actually went through all the material.
Yeah, so I'm excited to read all those because I think there's things, you know, personally I could learn from each one. The second one, I just was interested to see, obviously these optimization tools are really important, but I just, you know, that like, for instance, in Arizona, we have such diurnal shifts with our climate, you know, the weather day to day and the, you know, winter to summer, that, you know, just the complexity of the climate seems like it's another issue, how you opt, you know, sometimes you're wanting the heat and then sometimes you don't, you know, so that kind of adds another layer that would be interesting to talk to them about, but maybe it'll be in their paper.
Yeah, and I mean, in general, with the evolutionary algorithms, one of the things that at least Susanna and I have been extremely interested in is this notion of adaptation, right, rather than necessarily optimization, so that the optimization, it lies within the you know, potential and capacity to adapt and adjust, whether it's like a system design or kind of thinking about you know, material properties and other conditions of our interventions and architectures. And I was curious with Dr. Kayakoglu, I'm sorry, I'm sure I mispronounced your name, from the first paper. I maybe missed it, but I was curious what was the translation for the fabrication process with the computational tools, like what was being utilized to fabricate these folded topo walls, and are there other like tools that you're translating between these digital methods for low polyform with very specific fabrication, I guess, tools? Are there certain ones that you're using?
Well, we used 3 softwares. So Blender and Rhino and Grasshopper was for modeling and analyzing and generating, actually. And Pepakura, there's a software. It's very, very effective for unfolding the forms. And we used it to generate pieces so that afterwards it went through a laser cutting process. And it is all made out of paper. So this was one of the aims, to have a very light, structure, and underneath it there's a waffle structure actually, which is also helping this paper to stand by the wall. And it wasn't an easy process. It fell down a couple of times because the paper's quality and is very important in that one. So, and then we made some tests, and at the end, afterwards, it worked very well, but it's not able to stand for a long time. I can say that because it's a very dynamic, thing. But it was a really great exploration, and Pepakura is very, very practical, especially to model topographical, physical, to make the topographical physical models. Also in education, it is very effective.
I think it comes to a point where we're also talking about regional limitations. And that connects into the idea of regional parametricism, where you can consider, let's say, technology available in Arizona that wouldn't be available in Turkey or here in Brazil. And then you have to design or define parameters that would deal with materiality, social aspects of the single component that you want to absorb or incorporate into your design. So that you can respond to a local problem rather than just, let's say, replicating a solution that was made elsewhere. So that's a very interesting component. So I think Suzanne's question on how can we integrate this and going into this idea that you presented, Alethea, that you're pursuing dynamic responses rather than maybe optimized responses. There's recent work, especially one from Natalia Queiroz, that deals with multi-criteria optimization for sunlight and climate, similar to the second presentation, but also dealing with a more dynamic approach rather than just an optimized static approach. So there are papers recently published that go in that direction, and they're more in the field of environmental comfort. So you might be able to find some papers on that, either in solar energy or other specific journals. There's a lot of material there. Very interesting discussions, recent discussions. I think also Natalia published a paper in Arquitecturas del Sur that on dynamic facades as a dynamic response component that could be a reference if you're pursuing something on that direction. But I think the idea of regional parametricism in terms of materiality, I really like the idea of pursuing this volume with paper rather even than cardboard, in terms of trying to get something that's very, very ephemeral. So I thought it was a very interesting approach. I might explore that in my design studios. Actually, I will reference you on this and make sure that's give due credit for the idea of using paper.
We're about to finish. Carlos, if you can write down on the chat some of the publications Susanna was curious about. We're right about to finish. I think it's fascinating that we're all working in a field that is wide open, right? We feel like we're just getting started and we're finding all of these interconnections, and it's amazing.
Thank you very much for your work. It was very interesting for me to read and to watch all your videos. It was amazing to have you here. Thank you.
Thank you so much.
Thank you. Thank you.
Thank you.
Bye.
Bye.
Bye-bye.
Bye, everyone.
Bye.
Danielle, are you the moderator for the next session? Or SIGraDi Room A, Fred?